Welcome back to Max with RP. We have been doing a series of sessions on word problems involving maxima minima. We'll continue to work on the same topic. We'll do as many problems as possible. Now look at this problem. A tank with a rectangular base and rectangular sides is open at the top, is to be constructed so that its depth is 2 meters. So what is given? Depth is 2 meters and volume equal to 8 meter cube. If the building of the tank costs rupees 70 per meter square for the base and rupees 45 per meter square for the sides, what is the cost of the least expensive tank? So we have to minimize the cost. We have to find out what is the least expensive tank and what are we constructing. We are looking at the building of the tank costs for the base and for the sides. So we are looking at the area. Okay. So what is the area? Area will be, see, bottom is x and it's a rectangle. It's a rectangular base. So bottom will be x into y plus, if you look at the sides, this is x whereas the height is 2. So this will be 2x, but it will be there on both sides. So 2 times 2x plus, similarly the area of this side is 2 into y, 2y. There are 2 of them. So plus 2y. So this will be xy plus 4 into x plus y. Okay, now what is the volume? You are given the volume as 8 meter cube. It should be constructed so the depth is 2 and volume is 8. So this is a constant. Volume is a constant. What is the volume? Volume is base area into height. Volume equal to base area into height. X into y into is the base into height will be 2. Now this is given to be 8. So xy is 4 or y equal to 4 by x. Now a equal to, okay, what is it that we have to do? You have to first also use the fact the building of the tank costs rupees 70 per meter square for the base. Okay, so this is the base. So it is 70, cost function is 70 xy plus, this is the sides. What is the cost for the sides? Rupees 45 per meter square. So 4 into 45. 4 into 45 will be 180. 45 into 2 is 90. So 180 into x plus y. This is the cost function and we have to minimize the cost. Now it is a function of two variables, x and y are both variables. So cost function will be 70x into 4 by x plus 180 into x plus 4 by x. Let's simplify this. This is 280 plus 180x plus 180 into 4, 720 by x. This is the cost function. So 70, when I substitute for y as 2 as what? 4 by x, because 2xy is 8, xy is 4. So y is 4 by x. So I substituted y as 4 by x. X gets cancelled. 4 into 70 is 280. This is the base. Now for the sides it is 45 rupees. So there are 4 per meter square. There are 4 sides. So it is 4 into x plus y. 4 into x plus y into 45. Why did I do 180? Per meter square for sides. So it is 4 into x plus y 4 into 45. So 45 into 4. It is 180. Do you understand? So now I have replaced y by 4 by x. Now we have to find the critical point. So what is dc by dx? dc by dx will be derivative of 280 is 0, 180x is 180, and this one will be minus 720 by x square. Derivative of 1 by x is minus 1 by x square. Equate it to 0. So 180 equal to 720 by x square, or x square equal to 720 by 180. So this is what 36 by 9, which is 4, which means x equal to 2. So when x equal to 2, you have the least possibility of having the least expensive tank. But how will you justify that? I have to find d square c by dx square, which will be minus 720 into derivative of minus 1, 1 by x square. That is x power minus 2. So it will be what? Minus 2 by x cube. X cube is 8. So it is plus 180, which is greater than 0. Therefore, it is the cost is least when x equal to 2. So you have the least expensive tank when x equal to 2. So volume is given. You have to minimize the cost. The cost for the base is 70 rupees per meter square. For the size, it is rupees 45 per meter square. Because volume is a constant, I can write y equal 2xy is 8, or xy equal to 4, y equal to 4 by x. What is volume? Base area into height. Base area is a rectangle, x into y. Height is given to be 2. So 2xy is the volume, from which you get y equal to 4 by x. Substitute for y equal to 4 by x, differentiate and equate it to 0. You get the critical point to be x equal to 2. So we are saying that at x equal to 2, we should have the least expensive tank. Okay, is that true? How do you check? Check with the second derivative. Second derivative is positive, means we have a minimum at x equal to 2. Is it clear? Next problem. A window is in the form of a rectangle surmounted by a semicircle. So, a window is in the form of a rectangle surmounted by a semicircle. The total perimeter of the window is 10 meters. Perimeter of the window equal to 10 meters. Find the dimensions of the rectangular part of the window to admit maximum light through it. That means you have to maximize the area. The area is maximum, you will have maximum light entering through it. Okay. So now we will keep this as 2x and y. Let the dimensions of the rectangle be 2x and y. See, this is therefore x. When you talk about perimeter, you should only take the outermost boundary. So this line will not be included in the perimeter. Okay. So now what is the perimeter? This is 2x. This is 2x plus y plus y. 2y plus pi r. For a circle, the circumference is 2 pi r. For a semicircle, it will be pi r. R is what? X. So plus but pi x equal to 10. Okay. So 2y equal to 10 minus pi plus 2 into x. So I have written y in terms of x. What is it that I need to maximize? The area function. Now area equal to area of the rectangular portion, which is 2xy plus pi into x square by 2. Area of a circle is pi r square. For a semicircle, it is pi r square by 2. as you can see, it is a function of x and y. X and y are both variables. So I have to express one in terms of the other. Now this I am going to write it as x into, for 2y I can write 10 minus 5 plus 2 into x plus 5x square by 2. Okay, this is the area function. So area function is equal to 10x minus pi x square, pi into x square, minus pi into x square, then minus 2x square plus pi x square by 2. So it's now a function of x. So dA by dx will be equal to 10 minus pi into 2x, minus 2x into pi, minus 4x plus 2 pi x by 2. 2 and 2 will get cancelled, giving me pi x. Pi x square, if I differentiate, I will get pi into 2x. There is a 2 in the denominator. So 2 and 2 will get cancelled, giving you pi. So let dA by dx be equal to 0. This will imply 10 minus 2x into pi minus 4x plus pi x equal to 0. Okay. So 10 will be equal to 2x. So 10 will be equal to 2 pi x plus 4x minus pi x. So here it is minus pi x square and plus pi x square by 2 here. So plus pi x square by 2, if I differentiate 2 pi x by 2, so which is pi x. Okay, now I am equating it to 0. So when you take to the other side, this is 0. 10 I am retaining. So the other quantities will become minus pi x. So this will be 2 pi x minus pi x is pi x plus 4x. This is pi plus 4 into x. Therefore, x is equal to 10 by pi plus 4. This is the critical point. So we claim that when x equal to pi by pi plus 4, this is pi plus 4, we will have maximum light. How will we justify? We have to do the second derivative also. So d square a by dx square will be equal to, so that is differentiate this statement. Differential of 10 is 0. Minus 2 pi x will give me minus 2 pi. Minus 4x will give me minus 4. When I differentiate pi x, it will give me plus pi. So this is minus pi minus 4 less than 0. So A is maximum at x equal to 10 by pi plus 4. 10 by pi plus 4. So if x, what are the dimensions? 2x and y. So the dimensions are 2x and y. Therefore, now 2x, what will be 2x? 20 by pi plus 4. Now how will you write down y? 2y is this. So 2y is equal to 10 minus pi plus 2 into x. X is what? 10 by pi plus 4. Therefore, let me just remove this part. Okay, so this is 2y. So 2y is equal to, so I'm taking LCM, 10 pi plus 40 minus pi minus 2 into 10 by pi plus 4. Okay, so 10 pi and minus 10 pi will get cancelled. So it will give you 40. 10 pi and minus 10 pi will be cancelled. So if you want, I'll write one more step. This is 10 pi plus 40 minus 10 pi plus 20 by pi plus 4. 60 by pi plus 4. So y equal to 2y equal to 60 by pi plus 4. So y equal to 30 by pi plus 4. See, once I found out what is x, I have to prove that the second derivative is less than 0, so that we get maximum light. So we have already checked that. Now the question is to find the dimensions. What are the dimensions of the rectangle 2x and y? So if x is this, 2x will be, where I have written, 2x will be 20 by pi plus 4. But then I need to find y also. 2y will be 10 minus pi plus 2 into x. X is 10 by pi plus 4. I am simplifying this. 10 pi plus 40 minus 10 pi minus 20 by pi plus 4. So you get 60 by pi plus 4. That is 2y. So y will be 30 by pi plus 4. Is it clear how to proceed when you deal with sums which involves the outermost perimeter? Now look at the sum. This is also of the similar type. A window is in the shape of a rectangle surmounted by an equilateral triangle. Perimeter is 12 meters. So we will take this to be x and this to be y. Okay, so now what will be the perimeter? Again, I should not take this line, right? I should only take these two. Okay, now if this is x, you know that this portion is not there, but this will also be x. If this is x, this is an equilateral triangle, so these two will be x. So perimeter will be 2x plus 2y plus x equal to 12. 3x plus 2y equal to 12. What is it that you have to maximize? Largest area of the rectangle. So area will be, okay, area of the rectangle is x into y plus root 3 by 4, equilateral triangle, root 3 by 4. See, the whole thing is x, root 3 by 4 a square, right? So it's root 3 by 4 x square. What is the formula for area of an equilateral triangle? Root 3 by 4 a square. Here instead of a you have x, so root 3 by 4 x square. From here 2y is equal to 12 minus 3x. Okay, so this is x into y is 12 minus 6 minus 3x by 2. 6 minus 3x by 2 plus root 3 by 4 x square. See, in the perimeter, I should not include this. That's the most significant point. Only these two sides have to be included and these three sides to be included. So 3x plus 2y. 3x plus 2y is 12 because the perimeter is given to be 12. From which 2y is 12 minus 3x. Area is x into y plus root 3 by 4 side square for an equilateral triangle. Side is x. So root 3 by 4 x square. For y, I have replaced it. X and y are variables. So I have replaced it as y, 2y is this, so y equal to 6 minus 3x by 2. I have substituted. So the area function will now be equal to 6x minus 3x square by 2, 6x minus 3x square by 2 plus root 3 by 4 x square. So dA by dx will be 6 minus 6x by 2, which is 3x, plus root 3 by 4 into 2x, which is 2, which is 6 minus 3x plus root 3x by 2. Okay, now equate it to 0. So you will get dA by dx is equal to minus 3. So if I equate it to 0, so what will I get? 6 minus 3x plus root 3x by 2 equal to 0. 6 equal to 3x minus root 3 by 2x, which is x into 3 minus root 3 by 2. So which means x is equal to 6 by, what is 3 minus root 3 by 2? 6 minus root 3 by 2. So into 2 by 6 minus root 3. 12 by 6 minus root 3. So we have found x. Now what is it? Y. Substitute and find the value of y, because you have to find the dimensions of the rectangle. Y, this is x. So y will be what? 6 minus 3 by 2 into x. 12 by 6 minus root 3. 6. So 6 minus 18 by 6 minus root 3. Okay. So this is what? 6 minus root 3. This is 6 minus root 3. Y equal to 36 minus 6 root 3 minus 18. 36 minus 18 is 18. So this is 18 minus 6 root 3 by 6 minus root 3. So this is your y. I want you to check, because I am also doing the calculations directly. You also check whether this is the same answer you are getting, or there is any, there is always a possibility for an arithmetic error. Now what about the second derivative? What else is left now? We have to check the sign of the second derivative. What is d square a by dx square will be, you have to differentiate this, minus 3 plus root 3 by 2, which is less than 0, because minus 3, root 3 is 1.732 by 2. So definitely it is less than 0. Therefore, a is maximum. When is a maximum? When x is 12 by 6 minus root 3 and y is 18 minus 6 root 3 by 6 minus root 3. So it is mainly just calculations. So the most important significant point is, you should understand what is the meaning of perimeter. Perimeter is the outermost line. Anything which is inside is not included. But here you have to understand this is an equilateral triangle. So these three sides, if I draw here and complete, the three sides will be of equal length, which will be same as x. That is why I have taken the side of the equilateral triangle also to be x, and the side when the sides of the rectangle are x and y. I hope you found this session useful. So please practice these problems. We will solve plenty of problems until you are going to be very confident about solving problems involving maxima, minima. If you found this useful, please share it with your friends. Until next time, it is goodbye, and I hope you are working hard, and wishing you all the very best. Thank you.